Welcome to Deep Tech Musings. This is Pronojit Saha. In today's episode, we will be talking to Vishesh, who is the co-founder of SkyServe.ai. It's on a mission to democratize Earth observation by providing easily accessible real-time insights at a cost that's more affordable for the customers. In this episode, Vishesh will give us an overview of the Earth observation industry, its current state at world level and in India specifically. He also highlights what challenges exist in the industry and also what opportunities lie ahead, especially in terms of AI/ML application. So let's get started. Hi Vishesh, welcome to the show.
Hi, Pronojit.
So let's start with learning more about your background, right from the education days to the professional experiences you have had till SkyServe.
Yeah, first of all, thanks for having me. I have a bachelor's degree in aerospace engineering from IIT Kanpur. I graduated in 2011. I had a brief stint in IBM, and then I joined Team Indus. It was an aerospace startup in India. We were building a lunar landing system and a rover system. And I was there representing the guidance navigation control team. So I was there for more than 6 years and starting from scratch, initially without much guidance, was involved in developing algorithms, developing and proposing systems. Around me, we had a team of 9 people at a point and involved in various parts of the solution. So guidance, navigation, control, simulations, model simulation, and hardware and processor and loop simulations that do together. And we had come to a very mature stage of building our overall onboard flight software for the guidance navigation control for lunar descent, which was an autonomous system that we had made.
Okay, sounds pretty interesting. So did it finally went through some commercial application as well, or at what stage did we till develop it till?
So we left 2019 Team Indus. So there was unfortunately the system did not see the light of the day due to issues beyond our control. So, but we did take it to a stage where we were testing it, and the ideal test is to fly. So unfortunately that couldn't happen. So that's the precise reason we started SkyServe, and ultimately we would like to.
Okay. And so let's start by understanding this industry a bit more. So you're in the Earth observations industry. So what is it about, and why do we need the products that we are building in this industry?
Yeah, so the Earth observation industry will involve sensing Earth spatially and temporally through active and passive sensing techniques through flying orbital platforms. We need it for weather forecasts, agriculture, security, national security aspects as well, disaster monitoring, and a host of other applications, which we take for granted. And currently, it's a very important industry that will be growing. So particularly, the sensing techniques, as I mentioned, could be ranging from a host of sensing techniques. There are constellations of these satellites that are supposed to fly soon. So ultimately, the goal of the industry would be at the end that to get a real-time view of the Earth globally, 24/7. So we've not even got, 1% of that solution. Currently, existing industry is trying to deal with parts of the problem. So they're building certain kinds of sensors, a certain kind of constellations. But yeah, there's a long way to go.
Got it. So these, in a way, are like the eye in the sky for helping people on the ground. So predicting what kind of weather would be there, or for agriculture, like where is a good land, fertile land to check. And in case of security, might be tagging some illegal movements or those kind of things.
Absolutely. So in fact, agriculture is a big use case, primarily an agricultural country. And there's the amount of information that is produced. It's just a matter of time that Indian companies also take up the observation products, which they are. But it's just beginning to come up.
Sounds interesting. So, how is the market size in terms of the world stage and maybe India specific?
So I could give you a global view first. So, the Earth observation, you could break it into companies who are doing Earth observation themselves and companies who are using these Earth observation products. So the Earth observation companies, which who are making their own hardware, constellations, ground stations, and so on. This is the upstream industry. It's estimated from a 2019 report that it's a $9 billion industry. And the downstream industry involving analytics, value-added services, it's currently a $4 billion industry and growing. And currently, I would hesitate to put a number on the India market size because you might have been hearing many Indian constellation companies who want to deploy their own satellite and so on. So they're up and coming. So sometimes it's a number that somebody's estimation versus somebody else's.
Got it. And so help us understand the value chain and who are the primary stakeholders or the players in this Earth observation industry.
Right. Obviously, they're the satellite operators. So they make, build satellites, the payloads, telescopes, radars. Initially, from the industry started from the 50s onwards. Been primarily the government driving it, but very recently, commercial companies are coming up, and they are termed as these new space companies, and they would want to do almost all the things on their own. So the downstream analysis company is a separate set of companies. They are closer to the end customers. They know kind of what do they need. And so if I could talk about the private satellite operators, there's labs, plant labs, and many others. And the downstream operators are, say, Orbital Insights, Metrics, and there are constellation companies like Kongsberg, Deep Space. And obviously, the government companies like NASA, NOAA, NRO in US, ESA, CNES, DLR in Europe, JAXA, which is the Japanese one, and the Chinese one, ISRO, all these participants in this global industry.
Got it. So it has a healthy mix of government and private players, as you mentioned. And also, as I understand, so we have these satellite operators who are building and putting the satellites into space. We have these downstream analytics companies who are analyzing that data being calculated and making it useful for the use cases which we just discussed. And then there are these ground station providers. So what are their roles specifically in this, in between?
They essentially facilitate the transmission and the reception of data from the operating set of constellations or, say, individual satellites. So they establish, let's say, radio frequency links and gather the information and which hand it over to, say, the satellite operator for doing any pre-processing, say, image processing activities. Say they could make a geo-reference product so we know exactly where these images are. So they are also one of the critical roles that they play is to merge the gap between the operator and these analytics companies, and they are essentially the ones who are responsible to schedule passes in which, say, there's the data collection opportunity, so they establish telemetry and so on. So that's the role that
Okay. So, isn't it in the interest of satellite operators also to themselves be these ground station providers, or are we missing some other link here?
Well, there could be, as in, for sure, there are some companies who might be thinking about that, and there are. So ultimately, it's a question of taking a business decision. If it's a solved problem, and if it's a cost that you're willing to pay, rather than not reinvent the wheel and use the existing services. Or if you've got some ambitious goals of your own, you want to drive down prices, you might as well take a decision to build your own ground systems.
Got it. I think that's an important point which you made, and that makes sense. So next, I'm curious to learn. So what kind of threats may these observation satellites present to the society? And as a consumer or regulator, how concerned should I be about them, or is it not any real threat at all?
Well, that's a very good question, and quite a hotly debated one. So, if you open Google Maps, you probably could, happily count the number of military planes in the nearby Air Force Base. And in fact, today, a free and open data allows everybody to keep a check on everybody else. So that's one thing that is kind of out of the way, and probably everybody is happier for it, and even governments use them. The question comes on security and privacy, right? So these Earth observation companies have to operate according to the law of their land. So, for example, the Indian government's remote sensing data policy. There was one in 2011, and there was a draft vote in 2020 where images below a 50 centimeter resolution are term sensitive and are not allowed for distribution without authorization. So, you cannot easily make out a face or say, find out, okay, here's where, say, Pronojit is, track you. Also, when it comes to questions on, generally the fine print of privacy concerns is what matters, right? It will take a problem to propose a resolution. So we might need to, look at something which is triggered by a loophole in the existing laws to make these laws even more finer and more detailed.
Okay, so at a basic level, at least, the legal laws make sure that it's not possible for anyone to identify an individual through these observation units. So that should be comforting enough for the concerned user.
Yeah. Currently, the technology doesn't, as in known technology, I would say, is not capable to do that. Even as far as I've read, that even secret government technology is still not capable.
Oh, okay. But are there any such audits on these Earth observation companies by some regulator or government entity to ensure that there is, are they publicly traded companies have to go through a compliance for some governance and fairness? Do these Earth observation companies also have to go through any such compliance or audits for ensuring this privacy and safety aspect?
According to the laws, they have to. And these are safeguards that they're building, but I would say the amount of enforcement of these audits is something that I'm not sure about.
Okay.
Like, say, for example, the policies of various countries seem to exist, but commercially, people want to do more. And there's a clash that the audit should not stop business. And there's some friction there. So obviously, there are certain, basic rules that you cannot break. But as far as I understand, yes, those rules are being respected. But the amount of enforcement, it's generally, it's unless these things are clear and these guidelines or policies become law or they're enforced, I hope that these, things get more transparent.
Got it. Sounds good. Next, can you highlight what are the major challenges in this industry right now that it's facing towards its progress?
Okay. So maybe I could start with some technical challenges. So making real-time global Earth observation possible through smaller satellite constellation is one challenge that many companies are attempting. Also, providing actual actionable insights to those who need them on time and reliably. So insights are insights from the Earth observation, let's say active or passive sensing. And today, the supply of images is proportional to only those who can pay for it. And the value chain is unfortunately not built to handle the actual demand for those who need information. And also the demand itself as it exists, opening up. So new adopters, new kinds of players are coming in. So the volume of insights that are needed is something that needs to be matched by the supply. And from the non-technical aspects, as in regulations are important. It's important that they should be allowed, to have regulations should essentially allow easy implementation of laws. And new markets need to open up to the potential of observation for their business. Also, pricing today is driven by the large costs of development and operations of satellites and satellite constellations. The combination of regulation and price barriers haven't really brought in the contribution of the EO industry to the information age we live in. So it's there in a few tweets by, say, the or say or TV news channels with a satellite view of the, let's say, Ever Given, the incident that happened recently, or incursions into sovereign borders. But it isn't there for a mid-sized auto manufacturer to get a forewarning that there's an aluminium supply chain disruption by monitoring the supply chain itself. So it's possible through Earth observation, not been adopted so well yet.
Got it. So hear two key things there. One, where you mentioned that the value chain is not built to handle the demand. So what you mean is that the actual demand for the on-ground analytics is so much that the data is not able to bear with it, or is it that there's a dearth of satellite operators to cater to that data demand?
So generally, there are a bit of both. So operators are essentially, if you see that the rate at which the industry is growing, every few weeks you see that, okay, there's a set of satellites there for Earth observation. So there is an effort very actively to, build up supply in anticipation of this demand. And also there's the demand, which is, if you see the standard Earth observation providers pricing plans, it is very hard to enter. Like you need, I mean, it's not easy. You have to have a certain amount of area that you need to buy. Only then that order makes sense for them, and then would they accept. So it's a bit of both. So there's obstruction or barriers to a minimum entry for anybody, and on the other end, the amount of satellites that are there, they're yet to cover the true potential. And this could be a fair summary, I guess, from both ends.
Got it. So you brought an important point of affordability there. So that is key here, as you
Yeah.
mentioned. And on the non-technical aspects, so you mentioned that it's the regulations are not geared towards a small scale or a medium scale company looking to utilize this Earth observation insight. So, like, can you elaborate more on that? Like, do the regulations need to do anything specific to enable that, or what are you thinking on that?
Okay. So if I could just go back to the point here that, let's say, the enforcement of guidelines, they need to be ideally easy to be implemented. So say a guideline could be not taking an image of a sensitive area. And if it's that kind of an image is being shared, somebody has the authority to scrub that area, let's say. And ideally this is the say NRSC in India and some equivalent entity in outside. So ideally, if these things are to be implemented in scale, there needs to be implementation of these, of say, for example, this activity. It needs to be possible for a large amount of area automatically, and that's what very important. That when you got the point of say audit, it needs to be audited that sensitive areas images, let's say for national security purposes, are not being distributed. So there needs to be some active task forces deployed here. And a lot of times it happens that because of this, the delays get very high. As in, if I were to purchase imagery from some other place outside India, it could potentially take weeks. And these are for some kind of products for sure. So these are the kind of challenges that you face at if you were an analytics company. So this is something that probably will go away with coming few years. But yes, there's the laws and then there's the implementation of them. So that's something that I would like to see.
Yeah, it's some kind of a tighter integration which cuts down this approval or regulation time, maybe real time or maybe at least near to real time, so that the concerns of safety and all those aspects also taken care of, but the business making business sense, not having to wait for those insights for so long through these smaller requirements. That also comes through.
Also, I would also add one more point, say, the encouragement of local industries. So, there is so much of information that is there through the images that our satellites have collected. And the 2020 policy is actually very encouraging from that sense that some resolution, whatever the information exists, will be made free. So Indian companies should have the access to them. So to get even a heads up compared to the global players who've been doing this for a long time. And while you're reducing this, you should basically incentivize companies, give them access to information. There could be other ways to incentivize as well. So I would say it's from the government point of view is that we've taken a little bit of time to relax our policy, but you would also need your local industries to be encouraged a little more.
Okay, understood. So, what is the role of AI ML in this industry, and how has the usage of AI ML evolved in this industry till now?
So machine learning techniques, in fact, have been used in this industry for, if not more than, but at least 3 decades. And so it's been there from the start. And advances in computing over the last 2 decades have enabled more sophisticated, say, models or deep learning applications to be considered practical. And there is a very high quality application of AI/ML by companies like, say, Ursa Space, Space Node, Descartes Labs, and so on, who are providing general purpose ML models, while companies like, say, Ars Metrics or, say, Optical Insight, SkyTruth, these folks are having very application specific, industry specific insights. Now, these have all been applied on the ground. And we see that with our solution, we would want to push it up. And after images, essentially the current application is after the images have been received on the ground, then these models run inferences and give you some insight. And all these images that are coming down, nearly 20 to 40% of those images may not be so usable, because nearly 30% of the time when you look below as an eye in the sky, you're looking at clouds. So it doesn't give you a clear view of the earth all the time. So there needs to be models and a little bit of smartness that needs to be placed on board, so that such kind of images are discarded smartly and without losing information, reducing the infrastructure and cloud spends on an operational basis. These are key parallel efforts that these companies are also working on.
Got it. That's a lot of wasted data transmission, I believe, for each satellite. And so I think that's a big opportunity.
Yeah, so this is one of the first utilities that you could build. And think about that if you have someone intelligent on board in the sky and they have the ability to view not just your visible spectrum, but all the other spectra as well. So, and you have a lot of information to digest, on board.
Right. So along with these efficiencies, how do you see this industry evolving, say, in the next decade or so from here?
So the sector has a huge potential in terms of how we see the Earth, as in sensor spectra, to the time scales of observing it. So the revisit duration, so how long before you come to the same point again and you're able to show the picture of that place. And also the constellation size. So, and the variety of ways we can fuse multiple data sets to infer both about what we are doing as well as how the Earth is changing and being impacted by our action. So only recently has a single constellation been able to image the Earth daily in the Planet Lab, although with a visible band camera. There's a lot more to do in terms of data processing and actually converting observations to what we need. These algorithms will be placed upstream to make real-time inferencing and the arrival of high bandwidth communication systems. Next steps will be towards onboard reasoning and autonomy, ability of satellites to infer, reason, and act autonomously. So obviously these will be put in with safeguards, so operating these large constellations of satellites is not a trivial activity. Autonomy in AI will make these operations more predictable, more like running a large factory with more predictive maintenance and failover capability to ensure dependable services at affordable cost. I see that a lot of trend is towards AI and autonomy in space.
Sounds very exciting times. I think there is a lot of optimizations and new greenfield opportunities, as you mentioned. And this looks ripe for innovation. I do see a lot of movement in the space industry. And specifically, as you mentioned right in the beginning, in India also in the last few years, there has been a lot of movement, push, and the community is coming up very good over the few years. So exciting times ahead, I would say.
Indeed, there is the trend. You can define how the next 15 years look.
Right. I think that's more empowering, being able to sculpt and mold this industry, right? And having the knowledge and tool to do that. I think that's a very empowering vision.
Yeah, in fact, I would genuinely encourage everybody. So on this in this point that it just needs curious people, and if you derive pleasure or say if you have some motivation here, feel free to make these changes possible.
Yeah, I'm sure listening to you today and getting this overview of this Earth observation industry and what are the opportunities and how we can overcome the challenges and these exciting new innovations coming up. I'm sure quite a few people would get motivated to jump into this. Thanks for that.
Thank you.